Here are solutions to test number 1 for ECE 376. The first problem is with binary inputs. I want to convert temperature to a binary number. So what I want is something like this. At 60 degrees C, here are solutions to test number 1 for ECE 376. The first problem is binary inputs. I want to convert temperature to 0 volts, 5 volts. So what I want is at 60 degrees C, the output turns on at 5 volts. At 58 degrees, it turns off. So to do that, first thing I do is convert temperature to resistance. That's with a thermistor. It should wind up at 270 ohms and 252 ohms. I'll then convert to voltage if you pick R1 based upon your birth date. So I chose 1514 ohms. Your numbers are going to be different. At 1514 ohms, the voltage right here is going to be R over R1 plus R times 5 volts. I should get 0.75 volts and 0.71 volts. So at 0.71 volts, it turns on. At 0.75 volts, it turns off. So you're getting kind of this characteristic, a little backwards Z. When the on voltage is less than the off voltage, I connect to the minus input. The on voltage is your offset, and the gain is the slope. Output changes by 5 volts as input changes by 0.4. That gives a slope of 112. Make that 112 to 1. And there's the circuit, output 0 volts and 5 volts. Turning on at 60C, turning off at 58C. Problem 2. Problem 2 is for binary outputs. The PIC outputs 0 volts, 5 volts, limited to 25 milliamps. Come up with a circuit that can drive a 10 volt LED at 1 amp. So starting out, when this is 5 volts, I want to get 1 amp, well, based upon your birthday, 1514 milliamps. So this is 1514 milliamps. The voltage. This is a 10 volt drop across the LED. The transistor has 0.36 volts when saturated, leaving the remainder 9.64 volts across the resistor. 9.64 volts at 1514 milliamps gives you RC. RC should be 6.36 ohms. In terms of RB, the biggest this can be is 25 milliamps. That's all the PIC can output. The smallest it can be is IC over beta. So if I do IC over beta, that's the smallest it can be. That winds up being 568 ohms. The biggest can be 172 ohms. So anything in this range is fine. I would just use something like 330 ohms. Problem 3. What's the result of the registers after each assembly instruction? So we start out at 514. This says move port C to W. So 14 goes to W. Add port B to W, put the result in W. So 5 plus 14 is 19. Put the result in W. Add with carry, port C to W, put the result in port C. There was no carry, so 9 plus 14 is 33. Do a logical AND operation. W and 5. So 19 is 10011. 5 is 00101. And the two together, wherever there's two ones, they get a 1, otherwise get a 0. I get the number 1. So 19 and 5 is 1. Move port B to port C, so 5 goes to C. Set bit number 4 of port B. So 5 is 0000, 0101. This bit 0, 1, 2, 3, 4. Set this bit. So I get 10101. That's binary 21. Toggle bit 1 of port C. 5 is 0101. Here's bit 0, bit 1. Toggle this bit. Gives you 111, that's 7. Problem 4, how long does this code take to execute, where this is your birth month and your birth date? So the number of clocks will be 1, 2, 3, 4, 5, 6 times A times B times C. This section is 1, 2, 3, 4, 5, 6, gives you 7 times AB. This section is 1, 2, 3, 4, 5, plus 1, 6 times A, 1, 2, 3, plus 4. So add all these up, that's the total number of clocks. And that gives you 69,154 for this combination. Our B is make it equal to 20 million. The limitation you have is A, B, and C. The smallest they can be is 1. The biggest they can be is 255. So one combination that gets you close is 53 times 250 times 250. That's kind of trial and error. What it basically did is set everybody's 250 and then adjust A. Turns out it was close enough. So actually this is even closer. 53, 250, 251 gives you 20,047,572. And there's other combinations that exist. And finally, convert the flowchart to assembly. This goes block by block. To make port B input, I write FF to tris B. To make port C output, I write 0 to tris C. I'm going to put labels at each block to help with the code. At label 1, keep looping as long as port B pin 0 is equal to 0. So that's a bit test, skip at 0. I'm testing bit 0 of port B. If it's 0, don't skip, keep looping. If it is set, I skip out. Go to label 2. Increment port C. That's increment port C, put the result in port C. Label 3. Is port C greater than 15? So move 15 to W, do a compare, skip a greater, that's a byte test. If it is, I skip out. I skip, go to label 4. Otherwise, I go to label 5. At label 4, I move 1 to W, W to port C. Label 5. Is port B bit 0 equal to 1? That's a bit test. I'll test bit 0 of port B. If it is 1, I don't skip. I go back to label 2. Otherwise, I do skip, go on to label 6. Label 6 is port C equal to N. I'll move 16 to W, compare, skip if equal to port C. If it's equal, I skip, go to label 8. Otherwise, I don't skip, go to label 7. At label 8, I move 255 to port D. Go back to label 1. Label 7, clear port D, go back to label 1. So that's test number 1 for ECE 376.